video will provide a summary of topic 5, what makes a car go.
So in this topic, we've considered the question, what makes a car go? We've seen that in order to make a car go, we need to give the car energy. For a car, we give it energy when we add fuel in the form of chemical potential energy. In the engine of a car, this chemical potential energy is converted into work done on a piston, and this in turn is converted into the kinetic energy of the car. So this is how the car manages to get its energy, which it needs to go. We've seen that cars also require acceleration to start. We had a look at the kinematic equations that describe bodies undergoing constant acceleration, and we saw how these equations could be used to describe the flight of a projectile. We also had a look at Newton's laws. Newton's second law told us that we required a net force to be acting on the body in order for the body to accelerate. Newton's first law told us that a body at rest will remain at rest, or a body in a state of constant motion will remain in constant motion unless acted upon by an unbalanced force, which tells us that to start a car, we need to have an unbalanced force acting on it. And Newton's third law we saw was that for every action there was an opposite and equal reaction. So if there is no reaction force, if there's very little friction between the car's wheels and the ground, then it's not possible for the car to start moving. The wheels will just spin and the car will stay where it is. In this topic, we also had a look at scalar and vector quantities. We saw that scalars had a magnitude and no direction, such as energy and time, while vectors, such as velocity and acceleration and force, had a direction and a magnitude. We saw that in order to add vector quantities, it's useful to draw a vector diagram where we add these things head to tail. In the next topic, we're going to be looking at what makes a car stop. This is going to be a continuation of the branch of physics called mechanics. So we'll be considering similar equations to what we did here in this topic, but looking at them in a bit more detail, and we'll be looking at the frictional force in particular. So I'd recommend that you now attempt the tutorial problems, as by solving problems you will ensure that you truly understand this topic. So I hope that you've enjoyed this topic and that you've learned a lot from it.
Thanks to Sebastian Frick for filming this video.